everyone. Well, it might not be morning to where you are, but it is for me. I know the music might be a little bit loud right now. I will adjust that balance in a moment. But let me know if you can hear me okay. I'll be getting started in just a minute. You might hear more of an echo than usual because the audio filtering that I typically use is not on right now. All right, just let me know if this is my quick audio check. I'll be starting in about a minute and a half. Hello, everyone. Let's see here. Here we go. Let's turn this down just a tiny bit. Welcome, everyone, to a Monday morning Coding Train live stream. Probably not the most optimal time for me to have a live session, but it's the time that works for me. And so here I am. I'm attempting to get another screen over here with the chat that I might be able to take a look at it. But right now I can see the chat over here, and I see people greeting me from San Antonio, Texas, and chilly, rainy England. It is chilly, sunny New York right now. All right, so I'm going to try to get right into it today. Today, there's not going to be a lot of the usual Coding Train wasting of time because I have an agenda. So let's jump right in. I'm going to open up my web browser here and see if I can get to this particular page. Bear with me for a moment. And, oh, the other thing I'm going to do is I'm going to hit start. I'm recording this to disk. On the off chance I want to try to do something more with it. So we'll see. Unlikely this will just be available as an archive of a live stream, but just in case. All right, so first of all, hello, welcome. My name is Dan Schiffman. You are watching The Coding Train. This is a YouTube channel where I try to do a wide range of things, but mostly focusing on creative coding, making art with code, graphics and animation with code for the beginner. And yeah, I think that's a good summation of what it is this channel is. I also, this extra screen thing is not going to work for me, I don't think. Well, maybe I'll worry about that later. I also happen to have this full-time job, which keeps me very busy, teaching at a program called ITP and IMA at Tisch School of the Arts, New York University. And this semester, I happen to be teaching a class called Programming from A to Z. Now, I think, and apologies for all this, you know, what's the word for when I'm taking a really long time to set something up? I don't remember. Yes, so let me address something quickly in the chat. Oz Adi says, no pops in the mic today. So I did some debugging over the weekend about what was causing the pops in the mic. And strangely enough, I cannot believe this, it was NVIDIA Broadcast, the software I use that runs the audio through the graphics card and has various features for audio processing. And so this room that I'm in, this garage, is actually quite large, if I'm being perfectly honest, for a recording space, more space than I need, and it is not sound treated, and it is very empty, and it is very echoey. So I've just been using the reverb, the echo reduction that's in NVIDIA Broadcast. It works so well that I never bothered to sound treat the room. But so you might be hearing a little bit more of an echo today, which is also why I'm recording this to disk. In theory, if I wanted to edit this down to a shorter video tutorial, I could do some audio processing in post. All right.
I found this on the web. In theory, if I want to edit this down to a shorter video tutorial, check it out.
I did not ask for that. I don't know if did you hear that through the mic? This is this old iPad I found that I was like, oh, let me set up to have another screen where I could look at the chat. Because right now, although I see there's one message there. Oh, and Simon got their stickers in the mail. That's amazing. It just says enjoy the stream. So I've got a slight, and like, what's going on over here? This is this is a little bookshelf here. It's kind of like cut off there. I'm just not going to worry about it. There's a lot of flaws today in my setup. We're just going to move along. All right, so let's see. Programming with text. No, yeah, introduction. Yeah, let's see if this will get me somewhere.
This weird new tool is quickly becoming
Okay. You're really going to show me an ad right now? Thank you very much. Okay. So this is a particular, this course that I've been teaching at NYU for quite a long time, with this, as evidenced by this very old thumbnail design that really should be updated, is about different algorithms that you can use to analyze and generate text. So I look at things like just how, in JavaScript, how do you work with the JavaScript string object, loading text from a file, looking at regular expressions, some word counting stuff, some text analysis stuff, some node stuff, some database stuff, some speech stuff. So, I used to do Chrome extensions in this class. So this is kind of what the class was 6 years ago, and the current syllabus for the class is here. And you can kind of see all of the weeks right now. So a lot of the weeks 1 through 4, those old videos pretty much still apply. Weeks 5 and 6, I have some I recently recorded, and if you go to the Coding Train channel right now, you would see, just click on videos, the most recent videos that came out were, what I see on my laptop is what you see over here. Most recent videos that came out are, I need to do this. Were for working on bots. Then I've got some videos on Markov chains and context-free programmers that are coding challenges. But the material that has been entirely new this semester, I don't know if you noticed, it actually just had its 1-year birthday, I believe, but the world of language models and ways that people interact with text-based interfaces in our daily life now has just changed in extraordinary ways. That is very complicated, and I have lots of complicated feelings about that. So regardless of my own confusion and wondering about how I may or may not want to include some of these new tools and technologies in my own kinds of work and educational materials, I do see it as part of my, and Reiser, you asked, what is clustering sentence embeddings? I'm getting there. I do see it as part of my mission. Mission's too strong of a word, but I'm at least interested in doing some teaching around how to explore and learn more about language models, and in particular, I'm very interested in this topic of using embeddings for search and retrieval and other kinds of analysis of data. So Prathamesh says, are you checking the YouTube chat or the Discord chat? By the fact that I'm reading your message here, I would say the YouTube chat. I have a slight eye over there in the corner of I'll see one message in the Discord chat. So any urgent things that need to flag my attention, put them there. Not a sponsor, but this is Danielle is mentioning my thermos, and I really love it. I welcome a sponsorship from Fellow, I think it's called Fellow. I own so many of these. Yeah, it says it on the inside. And I have some very hot coffee in there. That was much too hot. Okay, so I've been having a hard time figuring out how to find the balance between all the different things I'm working on. So Coding Train, it's not like on hiatus, but it's a little bit hit or miss these days. So I always like to say at the top, thank you for those of you who are engaging and supporting the work that I'm doing, even when I'm producing much less as usual. Most of that, I'm not going to go too far into this, is because of my obsessive work on this Nature of Code book, which will be coming out in the summer, but you can read it all online. Lots more to come about that come 2024. But one of the things that happened, it was actually kind of funny because there was a fire drill. I was in the middle of talking about embeddings. And don't worry, I'll get to what that is as best I can. And I didn't get to finish some stuff that I wanted to do in class. And I have a bunch of examples here around working with transformers.js. Where's this going to go, by the way? Around this thing called umap. So I thought I would come and do a live session around it because I'd like to share this with my students who are in the class, but also share it with all of you, any of which might be a student in my class, but unlikely because they're very busy. They don't want to watch me on YouTube. So tired of me, I would assume by this point. I am in my garage in my home. So the other reason why I've been a little slow to do stuff, just a little behind the scenes here, is that I set up this whole recording studio. It's a little bit strong. I set up some equipment in my garage. And this semester, my teaching schedule is much busier than usual. So when I used to record videos at NYU, I was just there all the time when I was teaching, recording, whatever. Now I've kind of separated that a little bit, which I think is a good thing in the long run. But I'm actually at NYU like these last couple weeks of the semester, Tuesday through Friday. So today is my only day working from home, and I have, honestly, I have a lot to do. I probably shouldn't be doing this right now, but at least this is for my class. So it makes sense. Got to keep this muscle. Can't like totally lose the live streaming muscle. And yeah, so as long as I get out of here by like noon, 12:30 at the absolute latest, I'll be able to do all my other meetings and office hours and different things this afternoon, go in for the rest of my work week. And yeah, but really here, what I'm excited about, so just to set the stage a little bit, so many wonderful questions in the chat. I'm sorry I'm not really going to be able to answer them. This is not intended. I would call this a wintry hoodie, sweater hoodie. It's not intended to be a hoodie related to a very specific holiday that happens around this time of year that I do not celebrate. Even though my family insists on somehow, kind of partially at least, mostly celebrating. Oh, they'll get you there. Those rascally kids. It's wintry themed. It's pretty good. It's not that cold here in the garage. I was running the heater all morning and I turned it off now for sound, and it's sunny, so I'm getting some sun in here. All right, so Yeah, so here's the thing. I think I can just open up this example. And I'm going to log in as the coding train. I'm going to just show you the very end of this. I'm going to build the whole thing during this stream. Let me show you what's coming at the end. It'll be slightly different because maybe I want to use a different data set. It's hidden here. No, that's not it. Wait, where is it? Oh, I know it is. I messed up. I overwrote another example, and maybe I should fix that. Hold on. It's actually linked in a very weird place, which would be here. Yeah, it's like I messed some things up. But, oh no, wait, this is the right one? Oh no, this is with the slide. Oh my God. What? Everything is wrong. Okay, it's okay. I'm going to find it. I know how to find. This is, by the way, what actually happens in my class at NYU. I feel like I'm so prepared, and then I messed up a link, and I can't find the right thing, then nothing works. It's very hard. It's very hard. No, don't go here. Okay, don't worry. I'm going to get you this example. I know exactly where it is. It's right here. Okay, let's run this. I'm going to do share. I'm going to go to full. All right, and sorry for the very fast flickering here. I'm not doing anything fancy to animate this in any way. Frogo, I am streaming from New York State. That is about, I guess, the amount of information that I'm going to give here. So what you have just witnessed is, and I'll have to zoom in here for you to see a little bit more closely, is every function from the P5.js reference clustered according to a similarity metric. So I am basically I have taken a lot, you can see all of the loading functions are here. There's like some key related stuff here, some touch related stuff here, blend mode and texture is here. I'm not saying this is perfect or accurate to how it really should be clustered. What I have done, just to be the whole story, is I have taken a data file and let me get to that as well. Again, I want to build all these examples, but I already did them, so I might as well kind of show you the pieces first, and then I'll step through building it piece by piece. But I'm not completely prepared here, so let me find this other repo that I need to find, which is called Save Embeddings JSON. And again, if you don't know what an embedding is, you're in the right place. I kind of don't really either. I mean, maybe if you don't at all, then I probably know like a little bit more than you, so I'll be helpful. But I'm not claiming to be I'm learning this stuff along with all of you. I'm old. When I learned to code, we didn't have, ChatGPT. That's like barely that's like the, 1% of what I didn't have. Okay. Don't think I had this repo. Why do I have a passphrase here? Okay. Just bear with me. All right. I have this text file that I made manually, nothing fancy. I just put everything from the P5 reference, it's about 400 things, into this text file. So first of all, if you have an idea, okay, so first of all, I'm going to, every once in a while I'll answer a question in the chat. Wait, why? Why does this iPad just out of nowhere decide to talk to me? I'm going to, yeah, I'm not talking to you, Siri. Oh no, wait, don't say it. Amirali asks, can you make it 3D? So yes, one of my prompts to you will be, I'm going to show you how to do it in 3D, but I'm not, here, my overall goal here, and I realize I'm jumping around a lot now, which is why I shouldn't look at the chat probably, is to give you a very base level, without a design point of view example of how to do this. And my hope then is that many of you will find an interesting data set and visualize it in your own way. And I'll show you some other examples. The embedding projector from researchers at Google is a really good example of this that I will get to. All right, so this is a text file that has everything from the P5 reference. And what I have done is I have taken each one of those terms and used what is called an embedding model to create this embedding, which is a list of numbers. And then that is being brought in to a P5 sketch, if I could find it. Where? Here. And I'm using a particular algorithm, which is called umap, to do dimensionality reduction. And what I mean by that is all of those embeddings are a long list of numbers in a very high dimensional space, and I want to see all of those things plotted in a two-dimensional space, and umap is a particular algorithm that does that. So that is the full story from start to finish. The fly is back. Of this example project that I want to build without a lot of the details filled in. So if you will give me a minute here, I am going to, you can ask a few questions in the chat, and I could maybe answer them, but I'm going to just get myself set up here with it, and I'll put on a little music. All right, I am back. So let me take a look at the chat, see if there's any questions. So let me just answer a few of these questions real quick. Any reason to use umap instead of tsne? The reason I'm using umap instead of tsne is twofold. One, I heard it's the newer one that's better. I mean, that probably is not actually true. And there is a lovely JavaScript implementation of umap that runs beautifully in the browser. And so since that's available, that's what I'm using. Any chance you'll be doing the advent of code? I'm interested in doing it. This is my busiest time of year teaching, so I think I'm more likely to participate in January, which is coming in January. But I would love to do at least one advent of code. Maybe I can do like solve one and try to do it as like a YouTube short. Is there a way to cluster similar things together? Oh, okay, that's Raj is just explaining what's going on. But yes, to be clear, my P5 functions is just an example data set, and I can use any data set of text. And as long as the text is chunked into individual elements, I can do what I'm going to do in this video. So, for example, I could do lines from a Shakespeare play. I could do the list of P5 functions. I could do captions from one of my coding train videos. There are lots of things I could do. If you have an idea, the reason why I am using singular words, just as an example, is because it's a little easier for me to visualize because I can just put the words on the screen. If I'm clustering larger blocks, paragraphs of text, maybe I could represent those as dots and you hover over them and then you see the paragraph. So I could do that too. But if you have an idea for a data set that might make sense for me to do today in this video, you could drop it into the chat. I'll probably miss it. I don't know if we have any moderators here today because this was, one is I'm disorganized and I'm trying to reorganize for 2024 a new group of moderators. So if you're interested, come join the Discord. You could just if anybody sees an interesting data set and I miss it, feel free to, I don't know, try to highlight it for me. Certainly in the Discord member chat is where I would see it. Okay. So oddly enough, you're probably not aware of this, but I did recently cover a little bit of this in a live stream previously. And what I talked about in that live stream was just the idea of, I kind of talked about how I wanted to do this, and I hadn't done it yet. So I feel like I just want to kind of recap. I'm trying to think of where to start. Let's start with, I just need an eraser. Let's start with what is an embedding. Oof. Will one of these work? I have some wipes here. Just give me a second. This is why I'm recording to disk, because maybe. All right. Come on, little doohickey. I guess I should have done this before I started. I'll get there. By the way, and I apologies to, I forget the name of the company who reached out to me and I was in contact with about mounting a whiteboard on this wall. Anybody's got like a recommendation for like the best whiteboard I could ever possibly buy to do diagramming on for videos that I could easily light? I've looked into digital ones, but I don't think that's really going to work for me. But this one I bought from like an office supply store, and I put it together myself. And it's a little, one is I did a terrible job putting it together myself. It's a little bit clunky. Okay, so I'll leave a bit of what was on this whiteboard from before. What I'm doing today is very much connected to large language models like ChatGPT, like the Llama model, like Claude, in that those models use a particular deep learning architecture called transformers. I talked about this a bit in my last live stream. There's the famous, ancient paper now, 2018, attention is all you need. So I'm not going to, in this particular session, talk through what the architecture of a transformer model is, how they're trained, how they work. That's part of the materials of my class, and if you poke around in the syllabus, you'd be welcome to find that stuff. But it is highly connected because the same model architecture that is present in a transformer, a large language model, is present in what is called an embedding model. And I'm probably going to get this slightly wrong, but in essence, an embedding model, in my mind, and I'm going to oversimplify this, and I'd be curious to hear from the chat or anyone later watching this in the comments how accurate this is. But, well, let's actually, so I'm going to watch the time because I have a tendency to over-explain, but let's talk about it in this way. This is the way that I think about it, and maybe it will be helpful. So I've made a lot of videos about transfer learning. And again, I'm going off on a little side to come back to this. And with Teachable Machine, for example, maybe you've watched some of those. Feature extraction. So if I have an image classifier, and that image has a cat in it, well, let's say I don't have an image classifier yet. I have an image of a cat, and I'm going to send it into an image classifier. That image classifier is presumably going to be a convolutional neural network. And it's going to have a bunch of layers. And at the very end, it's going to produce a layer that's often referred to as logits. We could call those features. And then those will have an algorithm applied to it, usually something called softmax, which then turns it into a set of probabilities tied to a particular label. So the MobileNet model, which is what I use in a lot of my ML5.js and other image classification tutorials, has 1,000 logits for 1,000 labels, and presumably here at the end, this cat label, after softmax is applied, would probably have a very high probability, and we get that, aha, there is a cat in this image. So again, lots of details skipped here. You can find a lot of this in my other, Beginner's Guide to Machine Learning, et cetera, et cetera. I'm just taking an eye on the chat to make sure there's no, oh, and Nikhil is in the chat. Hi, Nikhil. Oh, good. Well, Nikhil, by the way, when I get everything wrong, Nikhil will correct it. You don't have to stay, Nikhil. And I'm going to show the embeddings projector in a little bit, which is, thank you for joining, Nikhil. Nikhil is one of the creators of, and if I've gotten that wrong, you can correct me in the chat. Okay, so one of the things that happens in a transfer learning process is that a model can be basically retrained to associate different labels with the logits, the features of a particular image. So in a transfer learning scenario, in a feature extraction scenario, the probabilities and their associated labels are no longer relevant. And instead, you just keep this list of logits, which is like a list of 1,000 numbers. And guess what? In my mind, these 1,000 numbers are an embedding for this image. Basically, let's say this image is, I'm not going to be able to do this math, 640 by 480. That's a lot of pixels. So what is the data if I wanted to have a numeric signature for this image? Well, I do. I have all of the pixels. And every pixel has an R, a G, and a B. And it's a lot of information. It's not really, it's too much. It's not that useful. I want to, in a machine learning context, boil the essence of this image down into something smaller, like a list of 1,000 images, 1,000 numbers. So that is the idea. Now, with an image, you could sort of think of it as like compression. It's not exactly right because we started with numbers and now we have fewer numbers. But what if I have, the cat in the hat? It's sort of like, well, I guess these are ASCII characters, but the ASCII characters aren't really associated with the meaning. So there's this whole process in a transformer model where first these are chopped up into tokens. The tokenization process is more nuanced than this, but you could think of it as like, oh, every word is a token or every syllable is a token. But the developers and researchers that make these models have their own ways of tokenizing text. And then each one of those tokens has like an embedding associated with it, which is like a list of numbers, and that's what becomes the input. And then there's all these layers of attention and blah, 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 blah. We're predicting the next token. So this is what I kind of talked about previously, and is the thing that I'm not talking about today, which is that if I feed the cat as an input to a language model, I'm going to get a set of outputs associated with probabilities. But in the same way, in my mind, in the same way that I removed the end, the actual predicted label from this image classifier, in a transformer model, I could remove predicting the next tokens, and just look at a lot of the internal numbers in the hidden layers. And somewhere in there might be the meaning of like have a numeric representation of the semantic meaning of what I'm passing in. So that, in my mind, is like an embedding. So I want to get an embedding for this piece of text. Now, this is such a useful thing to do, and you'll see why in a minute with some of the different things I might do. Retrieval augmented generation is another topic related to this. This is such a useful thing to do that there are models that are specifically trained and built and designed just for this purpose. And they're called embedding models. They're also sometimes, especially when I look at transformers.js, it's actually called like feature extraction. You know, a feature being a word to describe a property. I mean, that's a very common word in machine learning. I think of it as like, oh, my facial features. But we're doing an act there, right? If I have my actual face, whether it's a 3D model or a photo of it, I'm kind of saying like, wow, look at my nose. It's kind of got this kind of shape to it. Or, you know, boy, that tooth of mine is crooked. Those are my features. So machine learning extrapolates features from things, and those features are quantified into numbers through the, you know, all the different processes that are involved. Okay. So I'm going to wander back over. So that's loose explanation. I'm going to show you a couple other things that might give you a little bit more information. Wander back over, take a quick peek at the chat, and move on to now showing you how to use transformers.js to feed in a sentence of arbitrary length and get back an embedding. Okay, how does everybody feel about that? You can't respond to me. You can in the chat, I guess. Okay. All right. So I'm going to try to answer some of these questions here for a bit. Ari Sayan asks, are these logits tied directly to the model? Oh, sorry, I didn't change my view here, which I can. Are these logits tied directly to the model? For example, if you change the weight of the model. So this is a great question, and I think I want to rephrase it, because I think some of the terminologies may be getting a little mixed up there. So I think the short answer, though, I think is yes, in that, and again, I don't really have a diagram here, but let's think about this. So this is MobileNet here, this whole thing. This MobileNet's not here. This is the image input. This is the model. So the logits that will come out from feeding this image in are the numbers that you get because of the weights that are in the MobileNet model. It's been trained. If you were to change the weights of the model, you'd get different logits. So yes, if you had two feature extraction models for images, maybe they would give kind of like similar logits in some way, because if you fed the same image into them, because you know, lots of models probably look at images in similar ways. But no, you would not be, you know, if you wanted to do a similarity search across embeddings that were generated with different models, you're going to run into issues. Because I would think, because the embeddings you're getting are tied to the way a particular model was trained. And that's very important. This is not magic. None of this is magic. And it's a little bit easier to recognize, like, if the language model is going to predict the word cat after the cat in the, it's because of a, you know, it's because of the training data. You know, there's many examples in whatever, you know, training data set was used of the cat in the hat. So it's learned the high probability of hat appearing along with those, that particular sequence of tokens. So with there, it's easier to sort of then take the next step and realize, like, oh, there's a real danger of cultural bias and problematic behavior based on how that training data is collected and curated. There's all sorts of questions around copyright and authorship. So this is a really important, big discussion that I am very interested in. it's a little, sometimes it's harder to remember that that discussion still exists for the embeddings. Because even though all we're getting is the numbers associated with it, the fact that the cat in the hat is similar to maybe some other sentence is because of all of the same questions around bias and data collection in whatever data was used to train that model. So if two models with the same architecture were trained with the same data set, then if I used, and I might get kind of like the same results twice, would be slightly different. But yes, in the end, I think that to answer that question, I think, if I'm answering it correctly, these logics are calculated through the process of sending the pixels through the different layers of the convolutional neural network and all of the weights and activation functions and all that stuff. Okay, and I realize not everybody knows all of this, and that's fine. Stay with me here. Okay, so I don't see any obvious. I see people answering other people's questions in the chat, which I'm thrilled for. Okay, so let's just come back to this for a second. I'm going to show you this particular example. So what this example is showing you, just as another note of what you can do with this. So one of the things that embeddings can be used for is. And I might get some of these terms slightly wrong, but like a semantic search or a similarity score between two blocks of text. And so here's a scenario I'll give you. Let's say you're programming a chatbot, and your chatbot knows 10 answers. And you basically want to, whatever somebody asks, you want to give them one of those 10 answers. Maybe an 11th answer is I don't know. So let's say the question that's asked is, what color is the sky? And one of your answers that you have is the sky is blue. And I think if I go up here, or I can, here's what I'm. So what this particular example is doing, and let's see if I can, do I have it open? And this is not what I'm going to code today, even though wow, I'm at 11:15 already. But I think it's good background for this, and it is one of the examples you could look at. I think it's here. No, that's just a test. Is this. So, and I'm conflating the idea of questions and answers. I just put everything into one array. But imagine I had an array of questions and an array of answers. Basically, if I can create an embedding, if I can turn every one of these sentences into a list of numbers, then I can start to do math with those numbers, and whatever results I get from that math, I can tie it back to the original text. So for example, I could look and say, which one of these, if I take what color is the sky, which one of these other 1, 2, 3, 4, 5 sentences has the most similar numbers to what color is the sky? Now we've got to talk about what does it mean to look at whether the two sets of numbers are similar, but just from that, you can imagine if I just had one number, well, this one is 6 and that one is 5.7, those numbers are kind of similar. So that's how I can match, that distance, that difference between the numbers. So what this is showing you, I think someone said in the chat, it's like a comparison matrix, which basically you can see I'm mapping the similarity of two sentences to a color. So all down the diagonal, of course, I'm getting 100%, my mug is in the way there, a similarity score of 1. Because they're exactly the same, 100% the same. And here, I'm getting a similarity score of 0.07 because the sky is blue and what is an apple aren't very similar in terms of meaning and structure or whatever other qualities that we might attribute to how the embeddings were created. But the sky is blue, and what color in the sky, that has a 10 times higher similarity score. So another thing that I could build right now is that chatbot question and answer thing. And I'll also just briefly mention, I think I talked about this previously, if you look up the concept of, there's a great, Replicate, by the way, is a hosting service for models that I've been using a lot of. Also not a sponsor, but has generously given me a lot of credits to use because these things cost money, although what I'm going to show you with transformers.js runs on device, so it does not cost money. But they have a nice RAG tutorial, how to use retrieval augmented generation, that explains this idea of retrieval augmented generation. So what that means, and I have some examples, I'm watching the time, I want to show you my retrieval augmented generation example that I built in Node. but I'll come back to that if I have time. So that's another place where you could use it. Let me just tell you what I mean. And actually, Nikhil was in the chat. Do I have this? I think I have it. I'm going to open up. Nikhil is one of the founders of a startup called Lilac. And I think if I think this is it here. Yeah, restart this space. I'm restarting Lilac. Nikhil helped me build a RAG for the Nature of Code book. Let's see if it wakes up here. I should disclose that I do have a business relationship with Lilac, but you should definitely check out the work that they're doing. Let's see if this can wake up. So what retrieval augmented generation is this idea of, let's say I want to ask a question, and I want the answer to not come from a large language model's prior knowledge, if you will, to use that term, but instead to actually come from the Nature of Code book. I could do a similarity search across the entire book. It's a question of how do I chunk up the book, but let's just say I chunked up the book in paragraphs. So I could ask a question like, how do you code a fractal? And then, I have, maybe I'll run my own example of this while we're waiting. I'll just show you. Don't tell me it's not in here. Example, RAG, replicate. Let's see. Let's see if this runs. So if I could write a question, this is going to take a little while because this is using a replicate platform. And so they might have to like boot up the model, but I'll ask here, like, how do you program the Cantor set? I know that's the example in the Lilac. Oh, wow, that went really fast. Oh, did I change? I think I changed the data. I forgot I was messing with this example. And I changed the data. This is now actually not my Nature of Code book, but a transcript. A transcript of my processing tutorial. I'll show you how I know this for sure. I'm going to ask, who is Daniel Schiffman? Or let's say, I'm just going to say, who is Schiffman because, oh no, it's fine. It's fine, let's do that. Right, so you can see it's searching for in my video transcript things that are related to that question. And you can see I'm about to get started, but I want to talk to you a little more about just sort of me and my background, and also a little bit about, if you'll indulge me, the history of processing itself. So I could say like, what is RGB color? So this is not searching through the Nature of Code book. It's searching through a transcript of everything I said in a particular video. And so that's the retrieval. The augmented generation is I could say, hey, take all of this and give it to a language model and say, could you answer this question? Here's the knowledge you need to answer the question. Don't use your other knowledge. That's the idea of retrieval augmented generation. And this example does do all of that, but I was mucking around with whatever version. The version on GitHub does all of that. Let's just see. And maybe this will come back. All right, so that's a little bit of some background. So now, finally, I'm actually getting to what I wanted to do, which is let's start getting embeddings. Now, Massimo has a great comment too about Llama 2, but Bogak's question is really important. There are many different models for embeddings. There are many fewer models for embeddings that work on device. So one model that works on device is all mini LM-L6-V2. I'm going to use BGE small 1.5, I think, today. Most all of these models are embeddings for the English language. And my apologies in advance for not being as knowledgeable about what is out there and available for other languages. I think it's a bit of a problem that a lot of the research in language and AI is very English language focused and centered. And I would love to hear more about initiatives and work that I can support and participate in that is expanding the technology to other languages and cultures. There's so many reasons why that is important. So I haven't done a deep dive into this. Country name data set. That's pretty interesting, says Youssef. That's a great suggestion. But so let's look for the model that I'm going to use. Let me close. Oh, I closed that. It's fine. I'll come back to it. So the model, let's go here. So first of all, so my understanding of the sort of current, and I guess why is my, if you're having trouble seeing anything on the screen, please let me know. I just lowered the desk because I think it's blocking quite a bit. My understanding is that the current latest and greatest model for English embeddings, and I believe this particular research group also did a version with the same technique for Chinese, is BGE large. So we could click over here. Oh, this is replicate examples, but I think I'm looking for is the paper. Yeah, so this is the paper for the research group that has worked on these particular models. It's from the Beijing Academy of Artificial Intelligence. A lot of these models are published on Hugging Face, which is another platform for hosting models. And I could see right here, I wonder if it's actually going to let me do this without even logging in. I could say, you know, the cat in the hat, and I could run it. And this is going to run on Replicate server and give me an embedding right there. So personally, if you look at the GitHub repo that that is accompanying this video under save embeddings-json, there are two scripts. One is embeddings replicate.js, and this one uses the BGE large 1.5 model hosted on Replicate. But to use this, you'll need to sign up for a Replicate API token, and there's a small cost per query to replicate. The one that I'm going to use today in this video is using transformers.js. And this particular, you'll see it here, feature extraction model runs on device, meaning it's actually running just on my light. It actually can run in the browser. But I'm going to run it through Node because I'll get to why. It's a little bit tricky. It's not tricky for regular JavaScript people to run in the browser, but it's a little bit tricky to get it to work with P5. So I'll get to that when I get to that. OK. And Kathy's pointing out there are lots of data sets on Hugging Face as well, and that include different languages. OK, so let's get right to it. So this is the particular model. I need to raise this up, I'm sorry. So please let me know. I'm going to try to be mindful here about not blocking. I guess I could just move myself down and still have my desk higher. This is probably a bad idea, but I'm going to just do this right now. Where am I? Keyed me. OK, unlock myself. Woo, there, I'm lower now. So my desk is still at the same height, but it is blocking less of the screen. OK. Oh, and thank you, Munzer, for gifting a Coding Train membership. Somebody will receive that. MB Lab received it. Wonderful. OK, now, some more background. If you have followed me at all, you have probably followed the fact that I use a particular library called ML5JS to do a lot of machine learning examples in JavaScript. And boy, do I have a lot that I hope to do soon, all about this library coming soon. ML5JS is built on top of TensorFlow.js. I don't think Nikhil's here anymore, but looked like Nikhil, one of the creators of TensorFlow.js, was in the chat briefly. So TensorFlow.js is kind of the OG, the original JavaScript library for machine learning in JavaScript. There is another one that seems to be gaining a lot of popularity, particularly in the language model space these days. Comes out of Microsoft, called Onyx.js. So what you're seeing here is that this particular model has been released with Onyx weights to be compatible with transformers.js. Oh, Nikhil is still there. Okay. So, so what's going on here? The Transformers library is Hugging Face. Again, this AI hosting company platform that I find to be quite useful, in addition to all the other ones that I find useful, has a Python package called Transformers. They have recently released a JavaScript version called transformers.js. It is built on top of Onyx, which is the other thing. So just like ML5 is built on top of TensorFlow.js, transformers.js is built on top of Onyx.js. That's probably where the similarity stops. But so just want to give you that background and understanding. So one of the things I'm actually personally investigating is if we were, as the group who works on ML5, to add language model capabilities to ML5, an embeddings model, for example, could we also include the Onyx backend in addition to the TensorFlow backend for that library? But all that I want to do here is actually use transformers.js so that I could get access to this embeddings model. So let's look at how we can do that. Now, first of all, not to overdo it here, but I'm about to wade into the territory of working with Node. And if you are unfamiliar with that, you won't, I guess you could stop watching right now and go look at these, but later I made a couple videos that's about sort of like the tools that I'm using and setting up a Node project. So I'm not going to do all that detail now, but that reference material is there. Okay. So let's go to here. So this is a new, and I got to just be mindful of where I am so I'm not blocking things too much. This is a new empty directory on my Mac. I'm going to say npm init-y just to create an empty Node project. Then I'm going to open this up in Visual Studio Code, and I'm going to create a file, and I'm going to call it a save embeddings.js. So usually the sort of default file for a Node project might be index.js or server.js. Most of the things I do are making a web server with Node. But this is just kind of like, I just want to write a script that I can just kind of run as a process. So I'm like the weirdo who uses Node in the way that everybody else might use Python or other kinds of command line tools, because I'm heavily invested in the JavaScript ecosystem for my teaching and other things that I'm doing. So, hey, there's plenty of other people doing all amazing, much more sophisticated and highly intelligent tutorials and educational materials on machine learning in Python. So go find that. But here I am, just digging into JavaScript again. Okay, so what am I doing here? So the first thing I need to do is I need to import transformers.js. If you haven't seen ES import statements before, I also covered that in those videos. But essentially, all I need to do, and I actually don't, is this. So I'm just going to put this right in here. So I want to import this particular Node package. Presumably, to use this Node package, I need to also say npm I for install. I'm just going to write install and install the transformers.js Node package. It'll just take a minute here. Wow, this takes longer than it usually does for me. Okay, now if I go back to Visual Studio Code, you will see here under package.json that I now have this particular dependency, transformers.js, from version 2.9.0. I should also say that because I'm going to use imports, I need to add to my package.json type module. Okay, and by the way, in case anyone's wondering, I do use Copilot. I've been experimenting with it a lot more recently, but I've turned it off for the purpose of this live session because I thought it might muck things up too much. So we're just writing our own artisanal, handcrafted code here in this coding train session. So I'm going to go back to the documentation, and this is what I want. I want to, so the way that transformers.js works is every model is called a pipeline. And there is a task, and then the particular model you want to use for that task. So for example, if I go to just the main transformers.js page and scroll down a bit, you'll see like, oh, I could do a sentiment analysis pipeline. Or I could do a question answering, or sentence similarity, or summation, or text classification. There's all these different, there's vision ones. So there's a ton of stuff you can do, and for every single one of these, like if I just pick, I'm going to do image classification. If I click here, you'll see, well, there's a video and some other, and it's actually, see, this is the thing. It's showing me quickly, it takes me to the Python code. Let's see if there's a JS version. So sometimes you have to do a little extra digging, because that didn't work. I didn't end up on the, maybe if I click here under models or docs. Yeah, this took me to the transformers.js docs, and you can see here, and apologies that I should make this a little wider now. You can see like, oh look, if I want to do image classification, I just load this particular model. Now you might be asking like, well, where is it loading the model? All I did was give it the name. So this is very common. ML5 works the same way. I think some TFJS models work the same way. These libraries have built into themselves the URLs for the cloud hosting platforms where the actual model files are stored. So you could download the model files and load it locally, but what I'm doing here is as long as I give it the name, the Transformers JavaScript library knows where to go out into the cloud, if you will, and retrieve that model. Now this won't work because it's got the keyword await in it. So for me to await the result of loading this model, I need to put this in a function that is modified with the async keyword. And if you're not familiar with asynchronous events and async and await, I won't go to my channel to find them, but a whole set of videos about that as well. But I'm just going to write a function called load model. Whoa, I don't know what that autofill was. Async function load model. And I could then write a main function. I'm just going to call it go. Async function go, and I put everything in this function, and I'll just like call it. I know I should probably put that below. And I'm going to say await load model. So the first step here is for me just to load this model. And I don't insist. For no reason at all. Okay. Brain, yeah. I get it. Where are we time-wise? 11:35, okay. I don't believe that Node.js lets you await in the global context. If I'm wrong about that, then my whole life is about to change. Let's also do this. And I can say, what do I call this? I'll just call this the embeddings model, or I'll call this like BGE, small. I'm just like making this up as I go. BGE model equals await load model. Okay? So now, let's take a look at this. Let's make sure this works. And again, if anybody's having trouble seeing the code or anything, please let me know. Okay, so let's run save embeddings. And it's going to take a bit, right? It's a small model, but it's going to take a little while. So while that is going, let's go back. And so what do I want to do next? What I want to do next is get an embedding. So we can see here, I'm just going to copy paste the example. This is different than, no, this is right. Let's just copy this example here and look at what happens. And I'm going to just have it be, I'm just curious, can I do it? I mean, it makes sense to do it with more than one, but I thought I could just give it a single string. I'm just curious about that, because I think that'll be a little bit simpler right now. Did it load that model yet? Thanks for my nice typo here we didn't see. So let's try running this again and see what happens. Okay. Oh, and I need to say await run the BGE model through that source. Okay. So first of all, we see like it's console log this huge JavaScript object, which you can see a lot of the properties and information about the model. Something that's really important here is this number 384. So that's going to be the length of a particular embedding. All right. Ari is telling me, what about a Node version 18.18, which I think is the version I'm using? Can you really? That's insane if I can do that. I don't believe you. Okay. Let's try this. Are you kidding me? Oh yeah, this is going to work? Since when? What? What? Since when could you do this? Oh my goodness. I did not know that. Oh wow, I'm going to go change all my examples. It's going to make my life so much easier. We do not need this function. Okay. Wow. I didn't think I could love Node anymore, and I really do love it now. All right, let's just keep it called as extractor. That's fine. All right, so what's happening here? What's happening here is I am loading this particular model. Its task is feature extraction, and the model I'm loading is BGE Small English version 1.5. There are other models that are compatible with transformers.js. Presumably you could train your own embeddings model, but that's the one that I'm using for here. I'm giving a source text, hello world. This is not me. This is not a coding train example if I don't instead put like choo choo. And then I am passing that text to the model. And then these two properties, pooling is just modifying a particular aspect of what's happening inside of the feature extraction process. Probably relates to like, I actually don't know. Somebody can tell me in the chat. I'm assuming it relates to like, I think of max pooling with like convolutional neural networks. But obviously there's some aspect somewhere where it has to I'm guessing that there's like multiple embeddings, and maybe mean is saying just average them when you have multiple ones and you need to pool a bunch of embeddings together to just get one. Normalize means it's going to give me the values. I'm assuming, we'll check this, the embedding numbers that come out will be between some normalized range, maybe between -1 and 1 or between 0 and 1. So let's run this again. It's definitely between -1 and 1 based on these. Okay, so we got an embedding. Its dimensions are 1 by 384 because I only asked for one sentence. The type is floating point, and then the data, the actual numeric values, are in this particular property called data. All right, so for example, I could say embeddings.data index 0, and that's that first value. So for example, fly. Well, all right, so let's go a little further. Let's just make up a bunch. This is where I wish I had Copilot on. Copilot does the funniest thing if you're like trying to create a fake data set of sentences. It just starts making up sentences for you. It's kind of amazing. I don't know who's experienced that. Yeah, I still can't believe this thing about me not needing the asynchronous. I could just do await in the global space in Node. Like this changes everything. Cue like Hollywood, music or record scratch. I don't know what the sound effect that goes with that is. All right. Now we need to decide what is our data set going to be. So, here, I know a place I could look. I'm going to go to Corpora on GitHub. So this is a GitHub repo that I turn to very often when I'm looking for just like a fun list of things. So maybe let's go to film and TV. Game of Thrones houses, popular movies. Let's try that. How long is this? This is pretty good. Has the date. I'm just looking at TV shows. How long is this? Maybe let's do TV shows. It's a little bit longer. Let's do TV shows. So I'm going to do something kind of ridiculous here. I mean, this is JSON, so I should load it as JSON. I kind of want to just load it as plain text because that'll be more common to what you find. But let's grab this. Oh, here, let's just grab this whole thing raw. And let's go make a file called tv.txt. I'm going to paste it in here. And now I'm going to do some fancy regular expression searching. Let's look for a quote, the beginning of a line in quote. And so this is I got a whole set of videos about regular expressions, so I'm just quickly reformatting this document. And then I'm going to search for quote, comma, end of line. I realize this is kind of a ridiculous way that I'm doing this. I'm going to get rid of this. Let's just now search through. Did I get everything? Actually, the reason why I well, it's fine. Let's see if there's anything that was weirdly formatted. Good enough. Okay. How many TV shows do we got here? I guess it's 1,000. It said 1,000, didn't it? Okay, all right, so let me get rid of this and get rid of that. Okay, great. Okay, so now I have a list of 1,000 TV shows in a text file called tv.txt. Okay. So now what I would like to do is let's bring in the file system module from Node. Import fs from fs. I think that should do it. And I'm going to say the raw text equals await fs dot read file. Does it just, I forget how to use promises. I guess I could just use read file sync. Somebody will tell me. I'm just going to use read file sync. The tv.txt with the file format is UTF-8. So now I have the raw text, and just to be sure about this, let's console log it to see. I'm going to get rid of all this embedding stuff. Right? So there's all of the text files. And this, I maybe need to move this in a little bit so it's easier to see. So now I want to split it up. So shows equals raw.split by any number of line breaks. And let's look at that array. Great. So now I have an array of all of the TV shows. So presumably, I could load this model. Oh, I already did. I loaded the model here. I can now say for let show of shows and get. Now, again, it would be smart to do some kind of batch processing where I do like 10 at a time, and that certainly makes a lot more sense, especially if you're using a model in the cloud. But for the sake of simplicity, I'm just going to do it one at a time. So I'm going to get an embedding for every single show. And then I also want to have, I'm going to say output JSON is an object. And that object is going to have an array, maybe called embeddings in it. So essentially, I want to get the embedding, which is in embeddings.data. And for each one, I want to say output JSON.embeddings.push. And then I'm putting an object in it, which is got the show and the embedding, which is embeddings.data. And I guess that should be, it's a single embedding. So I think this makes more sense. So let's just see. You can all kind of check on me here if this makes sense. So I'm kind of thinking ahead here because I have made this example before. Show can be a const, says Supercrafter. That's a good point. So could output JSON. Not super in the habit of being that good as using const. So what this should do is as I look at, and let's do console log extracting embedding for show. I'll put that in as a console log. So if I get the embedding, then what I want to do, and this might make more sense, is to say something like well, I'll just leave it. It's fine. Basically, I want to, this is no semicolon here. I want to make a big JSON array of the show names with their embeddings. Because what I'm doing here is creating what you might refer to as an embeddings database. Now, there's no reason why I couldn't bring, later I'm going to load this database and do clustering with it. There's no reason why that couldn't be in the same app. But if it's, in my mind, if my goal is to do a visualization of a fixed data set that is not changing, it doesn't make sense to rerun the model every single time. So I'm going to do these as two separate steps, and I'll talk to you about how you could do it as one. Okay, so here we go. Let's run this, see what happens. So it's extracting all of these things. It finished. So I didn't do anything with the output JSON, so I don't know if it worked. But let's at least console log the output JSON. Let's write it to a file. Let's just write it to a file. So fs write file sync should go to the file name. So let's call it TV embeddings. And then I need to give it the, and I'm going to do const output equals JSON stringify. And what is it called? Output JSON. So what I'm trying to do, and I'll add in null, comma 2. So these arguments just format it. So for me to write this out to a file, it's a JavaScript object. I need to turn it into a string, into raw text, so I can write it to the file. So this should now, this isn't a lot of code. Very simple. I'm loading the transformers.js model. I'm loading a data set with raw text. I'm chopping it up. I'm feeding every element into the model. I'm getting an embedding. I'm packaging all of that up in a JSON object, JavaScript object, and writing it to a file. Let's just see. Is it possible that I didn't make a mistake here? We'll find out. Okay, see how fast that was, by the way? That's what I like about using an on-device model. Okay, this looks pretty good. Why is this no. No. Why did it do that? I mean, maybe it's going to be fine in the end, but this should be this. All right, I have to debug this, right? I don't want an object with every index being a number. Why did it do that? I don't recall this happening in my other experiments, but let's see. So let's just do one show here for a second. Is it something in the way that I did this? Okay, console log. I know I could just type, what do I type? CL, you were saying to me? CLG? I got some Visual Studio Code settings I need to figure out. Embedding. Let's just look at this. And then let's say break. So I'm just going to look at the first one. Okay, so I definitely got a nice plain actual array of numbers. All right, still just a nice plain array of numbers. Well, let's do this. Console log output JSON. Let's see what happens here. Oh, whoops. Oh, the break is before. Okay, sorry about that. So let's take this out also just to. Yeah, look, there it is. I wonder if this stringify did, so stringify clearly did something. let's see what's in here now. Yeah, okay. What if I take this out? Just It isn't an array object. Oh, okay. So I have to, because it's this special kind of float 32 array thing, it's not actually an array. You know, actually, I think transformers.js has this .list. I was looking at the documentation. I think I saw a .list function. Oh yeah, toList. So I wonder if I'm supposed to use toList. Let's see what that does. So this is useful for me to know. Is it what was it, toList? Oh, without the underscore. Okay, let's try this. Not toList. Does it go here? This is how okay. Oh, it gives it to me. Okay, so this is good. So maybe that's what I want. So I want this embedding toList index 0, because I'm just getting 1. I think this will now work. Let's see what we've got. And see here. Oh, let me put this back. I mean, I don't need the formatting. Well, I think my Visual Studio Code will format it. Yeah. Okay, great. That fixed it. That's what I want. I want to actually just see the array of numbers. Okay, so the formatting is very much unnecessary, but it's helpful for me to be able to see it. So I'm going to put that back in, null, comma 2, and then I'm going to take out this break, and I don't need the console log here. This should get me, and again, this is because I'm not batching them, so I'm just doing one at a time, which is probably not best practice, but it'll get us to the finish line here. Okay, here we go. Extracting all the embeddings. All right, we've got all the embeddings now, and there it is. Now, usually in Visual Studio Code, it lets me like fold these up, but it doesn't really matter. You can sort of see. Whoops, I hit save and it did something. So you can see that this file is not really human readable. And actually, one thing I'm very curious about is how big is it? Reveal in Finder. 9.5 megabytes. So one small problem here is that I wanted to show you how to do this in the P5 web editor, which I think is useful. The P5 web editor is, you can only upload files up to 5 megabytes. So I have a couple options. One is I could do this with fewer TV shows. Another is I could just host this file in a CDN somewhere. If anybody has any suggestions. All right, let's go move to the next topic. So I'm going to come back to that. So I have my embeddings. So you could imagine now there's a lot of things I could do. For example, I could make a chatbot where I ask the question, please suggest a TV show for me to watch. I love TV shows about farms. Now again, because the embeddings are just associated with the titles of the show, this won't work very well. But I could now turn my question into an embedding and then do a similarity search across all the TV shows and return a suggestion. More likely, if I really wanted to do this in a more robust way, I would want to do like embeddings based on like the description of the shows and all sorts of other, have much more information and data. And I would love to see people experiment with that. I got to come back and do some more of these like search and retrieval things. And the secret to it, which I had a diagram up on the board, is looking at something called cosine similarity. Okay. Host on the cloud would be nice. On GitHub, yeah, I could just host it on GitHub actually. So let's actually, for the sake of argument, just so you have access to it. It's not that different than what I already have, but let me just go on GitHub and make a new repo for this live stream. Embedding, I'll just call it, we can change the name of this later. make it public, create the repository, and let me just get this here, and then I'm going to say git init. Wait, actually, let's add a git ignore first. There's no environment variables, but let's just put that in there just in case I forget later. Maybe I don't want to. Right now, let's not upload the data files. So I'm going to ignore those as well. Oops. Code from live stream, and then add the remote. Oh wait, the whole point was for me to host it on the CDN. Okay, fine. I forgot what I was doing here. So I do need to include these things. Yeah. Oh, and that took out the package.json file too. I made so many mistakes there. I don't know if I need that, but I'm just, it's a reflex at this point. Okay. So now, here we go. The repo is there. There's no README. I don't know. Like, so one thing, I'm a little bit hesitant about this because I have this whole repo that I already made called save embeddings JSON. So this makes more sense. It's like documented, and I have like, you know, instructions and things. So I'm not sure, I'm not sure if I should deprecate this later and combine them. But for right now, it'll work because what I want is to be able to load this file. You can use a JS deliver link, but I think this will actually work. Just load these embeddings from this raw file. Okay, so let's now go to the P5 web editor. And let's see if, let me make the font a little bit bigger. So I want to move towards clustering and umap. Where am I time-wise? Oh, I'm at noon. I said I was going to be done at noon, but we're going to keep going because I want to finish this, by golly. Oh, just the TV shows on a gist. Oh, that makes more sense. Okay, I should have done that. So paste bin, yeah, the gist would have made more sense. Too late. It's too late for me. I've done this already. Okay, I'm trying to think. So there's two steps here. One is how to load that embeddings database into P5. That's actually not going to be too hard. I'm just going to use load JSON. So let me skip that for now. The other more complex question is around how am I going to take that data and draw a clustering map of all of those TV shows. And for that, I am going to use a particular algorithm called umap. Now, let's go to the embedding projector. This is a research project from the group at Google. I've name-checked Nikhil a bunch of times. Nikhil is one of the creators of this, along with Daniel Smilkov, and I'm probably missing lots of other people who worked on this. So apologies to that. This is a visualization of high-dimensional data that has a very thoughtful interface and demonstrates various different algorithms you can use to visualize that data. So first, let's talk about what's here. So the data that is being used to demonstrate, first, when you load the embeddings projector, is word2vec. What is word2vec? So you might think this whole idea of embeddings, wow, large language models, AI, we're living in the dawn of, putting words with numbers. This is not a new idea. And in fact, if you go back to my syllabus under the embeddings week, and I scroll down, stay at the top here, you will see that I even made a couple videos that I never finished, so I really should get back to it. And somebody just gifted like a gazillion memberships. Wow. Okay. I've never seen this happen, but thank you to Generate Collective. That is unbelievably generous and kind of you. So I made these videos. What is Word2Vec? Color vectors. That Understanding Word Vectors article is by Alison Parrish. It's absolutely fantastic. I would really recommend reading it. And the original paper around word representation in vector space is from 2013, so that's like 10 years ago. So there have been many instances and examples of looking at how to vectorize text, and Word2Vec being a particular model and embeddings database that has been used in lots of different projects. Universal Sentence Encoder is a TensorFlow.js model from 2018 that turns sentences into embeddings. So this is not new territory. I recommend this background reading for you. By the way, I've got some other links here to other reading material around embeddings that would also, I think it's good background material. So what this particular visualization is showing me is 10,000 words. Each of those words has an embedding of 200 numbers, and yet I'm seeing them in three-dimensional space. So what does this mean? Let's go back to the whiteboard for a brief minute. If you'll indulge me a little bit here. Okay, hold on. I'm breaking out the Windex, everybody. I don't like to use this if I don't have to, but it's gonna, water would be better, but you know, time is of the essence here. The Windex just does the trick. Now I'm breathing in the fumes. Hopefully, I don't know. Okay. Let's just get all of this out of the way. Get one of these nice cloths. All right, dry it off. Okay. So let's just say, for the sake of argument, that I have a word. Boy, this. That I have a word like rainbow, and it's associated with an embedding, which is 200 numbers. And I have a word puppy, which is associated with an embedding, and it has 200 numbers. Now, let's think about a different example. Let's say I have the word red, and it's associated with an embedding of just 3 numbers. And I have the word blue, and it's associated with an embedding. Oops. Damn it! Which is just 3 numbers. I meant to do this the other way around. And I have pink, and it's associated with, I don't know, 3 numbers. I don't know if that's pink, whatever. So if I wanted to visualize these 3 words according to their embeddings, well, I have a number of ways I could do it. I could do it with actual colors. But let's say I wanted to plot them in a 3-dimensional space. Well, I could consider the first number to be the x-axis, the second number to be, I kind of want to make the second one the z-axis, so that can I do that? Oh, no, that's fine. The y-axis, and the third number the z-axis. And then you could start to think like, okay, so red would be like over here, because it's at 255 along the x-axis, and maybe blue would be over here, because it's, so this is blue, and this is red, and then maybe pink would be kind of like, you know, somewhere like here. This would be where pink is. And you could start imagining plotting all these colors. Because each word is associated with 3 numbers, it maps easily to 3 dimensions. If I wanted to plot them in 2 dimensions, I could just do something like, well, let me just get rid of the y dimension. You know, I'll still just plot them. If some of them have a lot of green in it, I'm going to lose that information, but I'd still kind of have a basic visualization of the color space. What do I do if I have 200 numbers? Well, in an ideal world, I'd be some kind of like alien super being, like, you know, I don't know, think of those things in the movie Arrival or something, but I could just like see 200, I could just like, let me draw you a 200-dimensional space. And you're going to, this is my brain, I don't know about you, my brain does not work like that. I can't even, in my mind, visualize a 4-dimensional space. I can barely do a 3-dimensional space, if I'm being perfectly honest here. So there's not an easy way to visualize these numbers in a high-dimensional space. That's the information, though, is in that high-dimensional space. So what I need is some algorithm for dimensionality reduction. If I could figure out a way to take that and just reduce it down to 3 numbers, still retaining the essence of all of the numbers, then I could plot that and maybe glean something about the data. I could start to cluster them. I could do k-near. You know, there's all sorts of things I could do, like in the embedding projection, which I'll show you in a second. So the question is, how do I do that? Well, like with, I said here, like, why don't I just pick, I want to do it in 2D or 3D, I'll just pick the first 3 numbers. Sure, I'm losing 197 other numbers, but let's try that. You could actually do that. It's not a big deal. Try it. Go for it. I could maybe even do something like, well, what if I want to do it in 2 dimensions? Let me take the first 100 numbers and average them, and the second 100 numbers and average them. Again, that's probably not going to do, I'm going to lose way too much information. It's not going to retain the actual geometric structure and positioning of the 200-dimensional space, but that would work. That's a dimensionality reduction algorithm. So this is the task that I need to do. My data is not originally in 2-dimensional or 3-dimensional space, but I want to see it, visualize it in that space. How do I reduce these vectors down to a lower dimension and still yet retain as much of the information? I want things that would be near each other in 200-dimensional space to still be near each other in 2-dimensional space. So that's the problem at hand. Thank you, Fun Planet, who seems to be doing a heroic job of moderating the chat. I appreciate that. So this is the Energy Savers. Oh, wait, what the? I'm plugged in. Let me try. We've got a slight minor emergency here, which is that my battery, apparently I have not been plugged in. The battery is very low. I'm plugged. Let me check. Is this not plugged in? There is a plug that's plugged into an outlet. Is this? I'm afraid to turn anything off. It's got some cobwebs on it. Let's try plugging this in. Oh, wow, what is going on here? Oh, okay, hold on. Well, I'm going to unplug from the screen for a second just to plug this in directly to this one port that I know works. Okay, something is wrong with my power supply. Give me a second. I have a backup one. I have a backup power supply. Coming back. I mean, I could also, but people are just like, I've never seen this, all these gifting of memberships. I like forgot that I had that turned on. This is very kind of you. Okay, I guess I should do these live streams more often. Okay, hold on, I'm just getting another plug. Hopefully you can still hear me. Let's try this one. I cannot have my laptop die before I finish this. Now, this is very dangerous what I'm about to do. I'm going to try to plug it in from a different place. And it's a tripping hazard where I'm plugging it in. So, somebody remind me not to trip if I start trying to go to the whiteboard. Okay. We are saved, everybody. So I don't know what's wrong with this plug. Let me put it, now that I know it works here, I'll put it out of the way where I won't trip. Because as fun as that might be for all of you, it won't be good. Nothing good will come out of me. All right, yeah, so there's something wrong with that other power supply. So, okay, hold on. I'm going to be back to the tutorial in a second. I am recording this whole thing to disk. So it is possible, if there's interest, I would be glad to make an editing version of this. An edited version that's just the tutorial part, which might make it easier for people to rewatch later. But we'll see. Okay. All right, so I was talking about, so I want to make a version of this. So I was a little bit background around Word2Vec, right? And so we can see here that if I were to zoom into this, presumably words that are near each other are going to have sort of similar meanings because the 200-dimensional space of all of these words has been reduced down to 3 dimensions. Now, how was this done? Was it done by just taking the first 3 numbers? Was it done by averaging? No. It was done with a particular algorithm called, PCA, Principal Component Analysis. Let's take a look at it with a different algorithm called TSNE, which I forget what that stands for. At one point I knew. This will definitely be, this will 100% be available to watch later. I just was wondering if it might be helpful to have a shorter version of it without all of the me finding my plug and stuff in it. Now, this doesn't usually run so slow to me. I think it has something to do with the fact that I'm plugged into this streaming system. But you can see now the TSNE algorithm is moving the dots around, reducing the 10,000 points to 200 dimensions. And at some point it will finish, and we could start to explore it. I could even change it to 2D, and there's some, you can't see this down here, but there's even some various parameters and things that you could change. But, PCA, this is my loose understanding, is Principal Component Analysis was one of the first algorithms to do this dimensionality reduction. TSNE was all the rage a number of years ago. And more recently, umap is a new algorithm that, along some set of metrics, retains the relative similarity position. I'm trying to think of what's the best way to describe this. I should really just point you to this article, which will explain it much better. Data's global structure, that's the word I'm using. UMAP is a technique that offers advantages over TSNE, most notably increased speed and better preservation of the data's global structure. So this is a wonderful article from Andy Konen and Adam Pierce from Google Pair, People in AI Research. That describe, I believe these are the same authors as the umap-js library that I'm about to use. You can see Canonide here, which I assume is the same name. Might be getting some of these details slightly wrong. We're still going there. But so this article does a wonderful job of giving you a high-level understanding of umap. So first of all, this is, now what we're seeing here, which is nice, is the clustering of images. So if I were to make, again, I'm way over time already here, but I would love to do an example of this with images. I'm going to do it with text right now, but you can see the difference. This is using a particular data set called Fashion MNIST, which is basically lots of little low-resolution images of a whole lot of shirts, a whole lot of shoes, a whole lot of pants. And so if we look at this, you can see zooming in here, you can see a lot of the shirts and pants, coats and pullovers and shirts are here. All the shoes, sneakers, sandals are down here. UMAP has done this amazing job of organizing all of the data according to its similarity. It's not matching shirts with shirts. It's matching embeddings with similar embeddings. And it just so happens that those embeddings are coming from images. And these are low resolution enough that I'm assuming this is actually just done with the raw pixel data, as opposed to what I was talking about earlier with feature extraction through some image model. So you can read more. There's a couple different properties of UMAP that we'll see that you can change, and you can kind of play around with these different visual interfaces to kind of understand, like, well, what does it consider? How many neighbors that are near it in high dimensional space is it looking for to kind of map down to lower dimensional space? How far is too far? How close is close? And there's a bunch of different demos. This is one that was super interesting to me. So this is actually taking a 3D data, like from a 3D model, and doing UMAP projection. You could also call this dimensionality reduction projection. It's no different than how you might do projection in a 3D renderer, because you've got to take 3D data and create the illusion of seeing it in two-dimensional space. That is dimensionality reduction as well. So, but UMAP dimensionality reduction is doing, like, you can sort of see how it works here, and you can see what these parameters do. Like if I take minimum neighbors all the way down to 3 and minimum distance down to 0, this is how it's arranged this data into 2 dimensions versus increasing the number of neighbors and increasing that minimum distance. You can see, like, look at this strange, like, crazy version of this mammoth now in 2D. So this is ultimately what's happening, and there's a lot more examples and demonstrations and explanations in this article. So one is I've read this through. It really helped me. I cannot, regurgitate it in an eloquent way right now. I'm going to just sort of recommend that if you want to learn more about how UMAP works, that this would be your starting point resource. For us, however, what I would like to do is just go to umap.js. And there's probably a more elegant way to integrate this into your code. Oh, you can install it through npm. But I'm just going to, for the sake of using it in the P5 web editor, I'm just going to go under lib. I'm going to go to umap-js.js, and I'm going to just download this file. So I downloaded that file, and in the P5 web editor, I'm going to upload it. And where is it? Under downloads. Here it is. Let's upload it. And now in my index.html, I am going to include, I don't need, this is the sound library right away, so I'm just going to get rid of that. And instead include umap-js.js. So, and this is my UMAP clustering example. OK. It runs. We've got a sketch. OK, so now what I need to do is 2 things. One is I need to figure out how to run the UMAP clustering algorithm. And in fact, let's just do that right now with random data to start. And then I'll load in my JSON embeddings. So let's make a array called data. And let's make 100 random data points. And have each one be an embedding. I'm making this up as I go. A record. I don't know what to. This is like, maybe I'll call this embeddings, and I'll call this like data. Let's just make an array with 3 random numbers in it. And then let's push that into the embeddings. So what I have here, and OK, I got to keep an eye. Let me open this, which will help make sure that I'm not standing in front of the code. OK, so this is, I'm creating 3, I'm basically doing, where's the whiteboard? I'm basically starting with this. So I'm going to start with this, which is just embeddings with 3 numbers. And I'm going to try to do dimensionality reduction down to 2 dimensions. If I can get that to work, then I can load my higher dimensional sentence embeddings. OK, so now I don't know the UMAP library off the top of my head, so we'll follow the documentation. So I don't need to import it because I've just loaded it from the file itself. So I'm going to just create a new umap object. Let me just close out some other things running. Make my screen a little brighter. So I'm going to do umap. And I'm just going to use let. You don't need to tell me because I'm in the P5 world now. My friendly let place. And I'm going to say umap equals umap. And then literally all I need to do is say umap. I'm going to show you how to animate it later, but fit embeddings. So that should do it. Let's just see if I do it. Do I get an error or anything? Oh, it's slow. Wow. Oh, wait. 100 things just calling fit should not freeze. I probably should have paid more attention to what I was doing here, because I might not have the data in the right format. I can look at any of my examples. Oh, you know what I think is an issue here is I'm not setting the, all right, let me look at one. I made this example already, and I'm a little bit pressed for time here, so let's just go and look at it. Oh, right, and it's in my A to Z sketches. It would be, that's interesting. This is a different one. I'm looking for, I thought I made a hello world one, but let's just look at this. Yeah, so let's, oh yeah, I think I sort of forgot about like the important part. Okay, so I got to kill this page. Let's see if we can get it back. Okay. Okay. I missed some important things here, which is that, and let's just see, did I get that right? Yeah. I would like these to be on different lines because, okay, it's not going to do that. That's fine. Okay, so what did I forget? So one thing that I forgot that is really important is I need to give it some initial properties. And as that article demonstrated, these properties, n neighbors, minimum distance, those are parameters that affect the clustering. I shouldn't say clustering because clustering to me is really like actually putting them in, it affects the structure of the dimensionality reduction. How many other elements is it looking to get near? What is the distance threshold? Those are really important parameters you can play with. This is the one I want to really focus on. It is the dimensions that you want to end up with. So I started with 3-dimensional data. I want to end up with 2-dimensional data. Now, I might have done, maybe this like is a problem. Let me just put in the number. Let me just do this. It's kind of not what I wanted to do, but just to make sure. Let's just see if this now will finish and not freeze. Look at this for a second. Let's look at what the format of the data is in this one that was working. Sure. Okay, so this one worked, and it's just 120, and it is actually using just actual RGB values, so maybe I should just try that. This one's still frozen. Oh, fix line 8. Oh, that's the problem. I'm sorry, everybody. Okay. See, my naming is terrible. This is data. And also, by the way, just for fun times now, I realize I can make these 255. Okay. All right, everybody. We're moving on here with life. Okay. Great. Okay, it's working. So all that was wrong, in case you weren't following that, is I was being a lunatic and trying to put my array into my array, and I had an empty array full of itself, recursion, and then I was trying to umap that. Definitely not going to work. So let's just look at what is the data. What does the data look like? What are the data is probably what I should say. What are the embeddings? UMAP is expecting an array of arrays. So I have 100 three-dimensional embeddings. They're just color values. Then let's look at what do I get out. Let's look at UMAP. And maybe I'm supposed to, if I call fit, well, let's look at the documentation. Maybe it's just in there. Maybe I'm just being stubborn here. So learning rate, there's other things I could change. Random, categorical distance function, optimization state. I'm being so stubborn and not looking at my example. I'm like refusing to look at my example. Where do I get the results? Random spread, it's giving me my properties. I mean, I did it. I'm just refusing to look at the example. I'm going to look at the example. Fine, you got me. UMAP results. Yeah, no, wait. UMAP results. Oh, that's the array. Okay, hold on. What am I doing? Oh, I see. All right, fine, everybody. I'm just being silly. Okay, so how does this work? And I kind of hate what's going on here. I have so little room on my screen for the code. And I really want it to, I'm just going to make it a little smaller. You tell me, friends, if you can no longer read this on your tiny little phones that you're watching this stream on. Okay. Wow, that's way smaller. That's too small. I can't even read that now. Make it 28. Okay. UMAP is the object that is going to execute the algorithm and hold all the parameters. The results are returned from the fit function. Now, what I would like to look at are those results. And here, I now see I have all of that data mapped to 2 dimensions. Now, we have to ask the question of what is the range that I'm getting? Good question. I don't know. Ask the people who wrote that UMAP JavaScript library. Okay, hopefully you can. So what I'm going to do now, I think, so it didn't retain, the UMAP space that it projected it into is kind of an arbitrary space. And this is actually a stochastic function, meaning it uses random numbers, and you're going to get a different result each time. There is a way to pass a seeded random function into it, so you get the same result each time. That's beyond what I'm doing here. Basically, let's look at the following, just really quickly. Let's go and say, and let's make the background black. For let I equal 0, I is less than UMAP results.length. I++, and I'm going to say, I'll call it data point equals UMAP results index I, and then I used the const there, even though I said I wouldn't. Let's say let x equal data point index 0, and let y equal data point index 1. Maybe I want to translate to the middle of the screen, and then just say fill 255 and draw a circle at xy. That's 8 pixels. Let's see what we get. And I'm going to say no stroke. So you can see that's all of those points. But that's because the range, I haven't thought about mapping that range to my pixel space. So one way that I could do it is I could say, hey, let's map it's got a range between -1 and 1 to between -100 and 100. Maybe let's take the y and do the same thing. What's going on here? So in other words, this isn't a great way to do it because I'm just kind of grasping at straws. So what I actually would like to do, and I know I could use like some fancy higher order array functions to do this. Let's look for the smallest value. Oh, that actually is not so bad. Let's look for the smallest value and the biggest value. So I'm going to say x is data point index 0, and y is data point index 1. Let's get rid of the translate. I'll just do the mapping through what I'm going to do. And then I'm going to have some numbers like the minimum x should be negative infinity. Max x is positive infinity. Max x. And let's do that for the y. And then I don't need these temporary ones. I'm going to say the minimum x is whichever is lower. The minimum between, wait, do I say the max? No, the minimum x is infinity. The maximum x is negative, right? Because I need to start with the opposite of what I want to get, right? I want to find the minimum value. So first I'm going to check, is it less than infinity? Yeah. So I just had that wrong. So is the minimum between the actual value and what it thinks the current minimum is? And same thing for minimum y. Is this for y? And now I can do that for the max values. Whoops. And just change this to max. I look forward to all of you suggesting much fancier, nicer ways of writing this. And then now I can map from minimum x to maximum x to 0 to width. And then minimum y, maximum y, 0 to height. And because my random data is color, let's look at the fill as embeddings index I, index 0. So I'm going to just use the original embedding values to set the color. And this is very clunky because of the 2D array stuff. Now look at that. Woohoo! Okay, let's make it more colors. Let's do like 500 now. There we go. See what's happening here? Look, umap took those and clustered them. Look at all the greens and their else. Now, these are random. So let's do random seed, just so I'm just going to show you this. So I could say random seed, so I get the same random color data set every time. But I'm getting a different umap arrangement every time. It's because umap is a stochastic process, and it uses random. It tries things randomly and starts moving things around based on the random tries. That's probably not a super accurate technical way to explain it. Okay, so we're going to get to the sentence. We're going to get to the TV shows. We're almost there to the end. 12:36. Oh boy. Okay, I hope I'm not missing a meeting. I don't think I am. All right. So just for the sake of argument, though, I just want to show you that I could actually give it. Let's put this into like an options object, because I think it's a little bit more clear. And I can say, I can give it the P5. Ugh, God, I hate how I don't have space here. I can give it the random function from P5. There we go. Thank you, auto format. So now, because I seeded the random function, I'm telling umap to use the P5 random function it's the same orientation every time. So that could be important in different cases. Okay, so this is pretty good. And I could move right now to just using the embeddings. But let me show you one more thing. I'm going to duplicate this. I'm going to say umap clustering 2. And what I'm going to change it to now is, because especially with a large data set, it can run very slow. And so you might be waiting a long time for the final clustering. Plus, it's kind of fun to watch it. So I can say, let's see if it's here, fit async, looking for a step. Doesn't seem to be documented here. I don't know where I figured this stuff out. I must have been looking at an example. But I can just say initial. I think I know how to do this. So I'm going to say initialize fit. I think that's the right function name. And I'm also going to say umap is running. Or just going to say like, yeah, that's like umap running is false. And then I think I say, I should just look at the example. This is very silly. So I thought it would be in the documentation, and there's probably a different documentation that I could look at. But I've forgotten what it is. This one will have it. Step. Oh, I should have known that. And then get embedding. OK, that's all it is. OK, so then I'm going to say umap running at the beginning of draw. I want to do one cycle of the algorithm every time through draw. I'm going to say umap running is umap step. So step through one cycle of the algorithm. And then the umap results, basically, which I guess I can make that a local variable. Oh, so I think I can just call initialize fit. Umap results equals umap get embeddings. Or maybe, hold on, let me just check this. Yeah. Step. Umap get embedding or result? Yeah, OK. Then I'm going to say umap get embeddings. Okay, so what did I miss? Get embedding? There we go. So now you can see it's doing one cycle of the algorithm every time through draw. Now, it's never going to stop, but actually it will get to a point when it's finished. I just need to tell it to stop stepping. So I think that I say if umap running, then I want to call step. Because I still want to, oh no. If it's not running. Whoa, wait. Oh, but maybe I need to be running at the start. No? OK. Wait, what did I do wrong? Hold on, let's. OK. Oh, it's telling me how many. So that's giving it me, it's actually giving me a count. And is it going to go to like 0 or something? You can see it getting close. Huh. So this is not what I expected. Again, I've got to look at my example, which I keep closing because I really don't want to look at it. Yeah, that's what I did. Result, am I using the result somewhere else? And I started it as true. That's interesting. OK. I mean, I guess it doesn't really matter. umap running. How's this different? I guess I did the whole thing. Oh, OK. I had the whole thing here in draw. So anyway, there's obviously like a, so I might not have been doing this correctly. But I see that now it's doing it. So this is fine. I'm going to figure this out. So I'm going to say if, since I know it's going to do it, yeah, let's just do this. UMAP running is true. I'm going to say iterations equals UMAP. I'm just going to make my own version of this. Is greater than or equal to 500, or is less than 500. And maybe there is a way to specify it in the options. UMAP running equals false. And then, I mean, this is silly. I've kind of, I will refactor this later, as I like to say. If I think it makes much more sense for me just to do this. Okay. What did I? Yeah, okay. This should work, right? So basically, UMAP step gives me the number of iterations, and I want to keep calling step until I get to 500. So that should run through 500, and then we should see n epochs is the option name. So I could do that. So let's do that. Let n epochs equals 500, and then I could say n epochs here, and then n epochs here. So this would be a more proper way of doing it. Okay, sorry for that. Now you see this is now the UMAP algorithm running all of its iterations. And it's, even though it's a little bit, you could probably make a much nicer animation of this where you actually kept track of the points over time and then like interpolated them. But even so, I kind of love like now I could do like 2,000 points. And it's kind of like this lovely like mash of color that slowly over time starts to separate out into its positions. So even just visually here, I think something interesting is going on. But let's tie this all together. I'm an hour over what I meant to be, but that's fine. I'm actually doing this stream the dick in this project. Some amount of you have stuck with me for quite a long period of time. Many of you have been very generous in gifting memberships and things. Let's bring in that sentence data. So save, one more, duplicate, and now I'm going to put in function preload. I'm going to have a variable called JSON data, and my JSON data is equal to, and let's turn off the auto refresh. I need to go back to wherever I uploaded that embeddings database, which is right here. Let's go to raw. Let's grab this URL. And let's do load JSON that URL. And let's just, for the sake of argument, put in console log JSON data, just to make sure it's there. Okay, what did I miss? Semicolon is in the wrong place because I have so little space for my code. Okay, great. So you can see I got 999 embeddings. So that's good. I got 999 embeddings, and I don't know what follows that. Okay, so now the data, these are the embeddings. So I have a global variable called embeddings already. So now I'm looping through the length of the JSON data. And I am saying JSON data, oh, it's in a variable called embeddings. So embeddings.length. And I should really think about renaming these variables because I'm using the word embeddings in probably too many places. But I can take JSON data, embeddings, index I. So I'm putting all of those things into that original. This is ridiculous. Oh no, it's not. It makes sense. I have to, umap requires, I'm gonna change this to like raw embeddings. I think that'll maybe make more sense. So what I'm doing, and we don't really care about the random seeding here right now, so I'm gonna take that out. The raw embeddings are what umap needs. My embeddings are coming in with these JavaScript objects that are paired with the TV show name, which I also want. So I'm going to leave the same options. We're going to do all the same stuff, but now, instead of drawing a circle, let's try saying, oh, we are so close to being done here. Text, raw embeddings, oh God, I need a, no, not the raw embedding, the JSON data. Again, I could organize this better. JSON data dot embeddings index I dot, what did I call it? Show dot show x comma y. Okay, so I think what this should do now is, instead of the random color data, I've loaded all of the, again, remember, I've loaded all of the TV shows that have a name and an embedding. I've reformatted it into a raw embeddings array, which is what umap needs. And this should be raw embeddings here. Then I'm getting the results, visualizing them, but instead of circles, I'm drawing the actual text. Let's see what happens. Okay, great. I think this is working. So I'm going to stop this because it makes much more sense. I need a much bigger pixel space for this to be interesting at all. So let's do window width and window height. And I'm going to do, let's take out the console log. I think this is done. I'm going to do share and go to this full screen view. And let's see what happens. Sorry for how flickery, this is probably like destroying YouTube compression. After 500 iterations, we should see something. Not? Whoa, okay. Wow. I guess I was expecting to have something with a bit more structure to it. But I guess these show names are really kind of like wildly different. Curb Your Enthusiasm and 21 Jump Street. Yeah, those are basically the same show. I mean, 9 to 5. Wait, let's double check the code to make sure I didn't mess anything up. Number of neighbors, umap step. Yeah, I mean, I didn't change anything. So maybe this data set, I mean, I could try a different data set real quick. We could try playing with these values. But I also think I might need to stop now and let you all like try this with your own data and make more beautiful, interesting visualizations. Try 3D, be more thoughtful about the design and interaction. Can you zoom in and out? All that kind of stuff. I'm a little bit disheartened. Let's look at this. Let's see if we can look here again and kind of like, what happens if I get things minimum distance. Yeah. So lower minimum distance. Let's just try using some crazier parameters. Like let's lower the minimum distance and let's like increase the number of neighbors. I was going to put in 50 here and hit save and then hit refresh. Oh, also maybe I hadn't actually hit save before I went to the full screen, but let's see what we get. So Fun Planet says, isn't raw embeddings the same as embeddings? No, because the embeddings file is written in this way where the actual embeddings are inside these little Java objects with show and embedding, and umap-js is just looking for a 2D array. So that's me just reformatting it. Okay, let's wait for 500 iterations. The P5 functions worked so well that I just assumed any data set would kind of work. but I'm not getting really great results here. But I mean, it did do something. Like maybe if we did similarity scores between these, we'd see that this arrangement like really makes a lot of sense. But also this data set is kind of silly. Boardwalk Empire and Aliens in America. Are you smarter than a fifth grader? Cupcake Wars. Heck, that kind of makes sense that those are near. Name that tune. Yeah. Murder, She Wrote. Also, like this is like the worst visualization ever. So a pup named Scooby-Doo. So it's sort of hard to evaluate because my data, I picked a poor data set. I'm missing, are you sure? Am I missing something? Oh, I'm missing yet another. I think Fun Planet in the chat caught something really crucial. I think, so let's look at my mistake here. So this is my naming problem of calling everything embedding everywhere in my code. Look at this. Yeah, this array has objects in it that has the show, and that, so it is the same. So I made a huge mistake here. This needs to be, the whole point of this was to only put the arrays in it. Yeah, look at that. Now I have arrays of 384. Okay, hold on. We're going back. Stop. Save. I think we're going to get something now. I mean, we'll see. We still, who knows how, it's going to work. Other people caught it before Fun Planet. I just noticed you Fun Planet because you have the wrench. So thank you, everybody. Yeah, William Clark, I see, says it. Yeah. Now, it's definitely different. You can see it's quite different. And Easy Street, East Street, Flamingo Road, 21 Jump Street, yeah. So the embeddings are, obviously we're just doing it by show titles. You can see this little cluster here, the restless years, the living color, love of life. Okay, now we're getting results. Again, my visualization leaves a lot to be desired. I am curious. I think I'm an hour beyond where I meant to be. Let's just try. I'm just curious. I would love to do this now in 3D, but I got to move on with my day. But I just want to try changing those parameters a little bit just to see if we get more structure. So you could imagine, so one thing, I give you a lot of prompts here. One, try doing this with a different data set, smaller data set even. Try doing it in 3D. Think about if you can make this a navigable space. Like how could I zoom around, move in and out? Maybe I could hover over one and it would like link all the ones with a certain similarity score. Could I use like a force-directed graph? Like maybe these things are connected with spring forces and the spring force is related to its similarity score. There's so many possibilities here. I would love, there are some of you somehow still watching this. What I'm going to do is I'm going to turn all this off right now. And I am going to, might even be till tomorrow, although I welcome help with this. I will link from the video description to all of the code, all of the articles, all of the stuff that I explained in this. If you think it would be valuable for me to work with Mathieu, who does video editing for the coding train, to try to create, this was now a 2.5 hour, 10:30, 11, 2.5 hour live stream. I think this could probably get cut down to like an hour. We could try this with, I didn't get to show you how this would look with the replicate embeddings model, the BGE large. So there's so much more to this, but I hope that you learned something. This opens your eyes to some possibilities. Maybe you're inspired to make your own version of something. I kind of would like to do this with YouTube channels, actually. So I have to stop. I have too many, my brain is melted from building this whole example. But so if you want to engage with this more, go to thecodingtrain.com/discord. And also just check back in 3 hours, 6 hours, 12 hours, 24 hours. Tag me in Discord if it's not there. The video description for this live stream should be annotated with all of the links and code that you would need to reproduce this on your own. Okay, thank you everybody. I'm going to just put on the goodbye stuff and kind of, I will put on this little song here just to see if there's, I'll take like 1 or 2 last questions. And let me just look at my message. Okay. Sorry, I'm like looking at my text messages, which I don't need to be. I'm just an iPad. Oh, Jesus Christ. Okay. I love embeddings, the meaningful data. Thanks, Dan. Is there a neural network from Hugging Face that knows the semantics of your words? Yes, this is the idea of the embeddings models. Now, I think we have to be very cautious about how much intelligence or we ascribe and how much we really believe that these models are perfectly encapsulating the semantics of our words. They're all of the same kinds of cultural biases and issues that language models might have in how they predict and generate text. All of those same considerations exist in the embeddings models. However, I do think it is quite a tool, a powerful tool, to be able to work with data sets, to create art with data sets, to understand your data better, and there's lots of possibilities there for sure. This song is much too long because but let me just close out these windows to make sure everything's saved. I'm going to hit stop recording on my recording to disk. Hopefully, audio quality. Oh, you know what? Okay. Oh no. Okay, hold on. I think it's not a problem because, yeah, the recording to disk audio was being passed through NVIDIA broadcast. So it probably has all that like popping and stuff in it, but I do have I could archive the audio from the stream and put it together, so oops. So that might make it a little more challenging, but okay. All right, goodbye everybody. I will see you, I don't know when, sometime again. I like doing this. If you like just the live stream where I build a project like this, and this is useful to you, I'll be curious to see if this video has any life to it after this stream. That's why I used to like, anyway, I don't need to go into all that right now. Just thanks for watching. Come say hello in the Coding Train Discord, and yeah, that's it. As always, I always forget the this dot, this dot, this dot, this dot. I'm gonna do this dot, this dot. I'm gonna do this dot, this dot, this dot. I'm gonna do this dot, this dot. I'm gonna do dot, this dot, this dot, this dot, this dot song. This dot, this dot, this dot. Never forget this dot, this dot, this dot, this dot, this dot song. This dot, this dot, this dot. Never forget this dot, this dot, this dot, this dot. I'm gonna do this dot, this dot. I'm gonna do this dot, this dot, this dot. I'm gonna do this dot, this dot. I'm gonna do dot, this dot, this dot, this dot. I'm gonna do this dot, this dot. I'm gonna do this dot, this dot, this dot. I'm gonna do this dot, this dot. I'm gonna do this dot, this dot, this dot, this dot song. This dot, this dot, this dot. Never forget this dot. This dot, this dot, this dot. Never forget this dot. I'm gonna do the this dot, this dot, this dot, this dot, the this dot song. Never forget the this dot. Somebody compose that song for me.